Matter is everything around us. It is the air we breathe, the water we drink, and the ground on which we walk. In simple terms, matter is anything that has mass and takes up space. This includes solids, liquids, and gases. Matter is composed of tiny particles called atoms and molecules. These particles are so small that they are invisible to the naked eye. However, they are the building blocks of the universe, constantly moving and interacting. By understanding the fundamentals of matter, students can explore more complex concepts in physics, chemistry, and biology. In the following sections, we will delve into the kinetic theory of matter, explore the forces that act between particles, and discuss how matter can change from one state to another. The kinetic theory of matter explains the behavior of gases, though it also applies to solids and liquids. This theory is based on three main postulates. Firstly, that all matter is made up of particles in constant random motion. Secondly, that these particles collide with each other and the walls of their container with perfect elasticity. Lastly, that the energy of these particles increases with an increase in temperature. For instance, when water heats up, its molecules move faster and eventually separate into vapor, turning from liquid to gas. This principle is applicable to understanding weather patterns, engine function, and even the behavior of stars in the universe. Interparticular space refers to the space between the particles that make up matter. In solids, these spaces are minimal, as the particles are tightly packed together. In liquids, the spaces are larger, allowing the particles to move around more freely. In gases, the spaces are the largest, which is why gases can be compressed and occupy different volumes. Interparticle attraction is the force that holds these particles together. These forces vary in strength depending on the state of matter. For example, the forces are strongest in solids, which is why solids have a definite shape and volume. In liquids, the forces are weaker, allowing them to take the shape of their container but maintain a constant volume. In gases, these forces are the weakest, which is why gases expand to fill any container. The law of conservation of mass states that mass is neither created nor destroyed in a chemical reaction. This means the mass of the reactants must equal the mass of the products. For example, when hydrogen gas reacts with oxygen to form water, the total mass of hydrogen and oxygen used equals the mass of the water produced. This law helps explain why balancing chemical equations is necessary. Understanding this law is crucial for students as it reinforces the concept that matter is conserved and merely changes forms through physical changes or chemical reactions. This understanding is pivotal in studies related to environmental science, engineering, and more. Matter can change from one state to another through processes known as interconversion of states. These changes occur when energy in the form of heat is added or removed. The most common processes are melting, freezing, vaporization, condensation, sublimation, and deposition. Melting occurs when a solid turns into a liquid, like ice melting into water. Freezing is the reverse process, where a liquid turns into a solid, like water turning into ice. Vaporization occurs when a liquid turns into a gas, which can happen through evaporation or boiling. Condensation is the reverse of vaporization, where gas turns back into a liquid, like dew forming on grass. Sublimation occurs when a solid turns directly into a gas, like dry ice. Deposition is the reverse, where a gas turns directly into a solid, like frost forming on a window. Understanding the nature of matter is fundamental to grasping the physical world. From the kinetic movements of tiny particles to the conservation of mass in chemical reactions, each concept builds upon the next. The interconversion of states of matter demonstrates the dynamic nature of physical states, influenced by energy changes. For students, these concepts are not just academic. They are observable in everyday life. By understanding these basic principles, students are better equipped to delve into more complex scientific theories and applications. This exploration into the nature of matter is just the beginning, opening the door to deeper inquiries into the sciences.